14.3 notes. We are ready to evaluate trigonometric functions. It says reference angles allow you to find or to evaluate a trigonometric function for any angle theta. The sign of the trigonometric function value depends on what quadrant theta is in. So there's going to be 3 steps. And first period did really well with this. I was very impressed. Step 1 says find the reference angle theta prime. So that implies you need to sketch theta in order to find the reference angles. Step 2, evaluate the trigonometric function for theta prime. Step 3, you're going to use all students take calculus to figure out whether the final answer is positive or negative. So we're going to review this one more time. We did this yesterday. All students take calculus. What this means, sine is positive, cosine is positive, and tangent is positive. In the second quadrant, sine is positive, but cosine is negative, and tangent is negative. In the third quadrant, tangent's positive, sine is negative, and cosine is negative. In the fourth quadrant, cosine is positive, sine is negative, and tangent is negative. Everybody got it? Now, what I want you to do, I wrote mine on the front marker board instead of my smart board, but I want you at the top of this paper above example 5, draw the 2 triangles, your 30-60 right triangle, your 45-45 right triangle, and I want you to draw the unit circle with the 4 quadrant points. And you do need to remember that every ordered pair around that circle is cosine theta, comma, sine theta. So we're going to go through a process, and after we finish the notes, I'm going to ask you to take out paper, and we'll do practice problems. But you should be able to evaluate these without looking at the purple unit circle paper, okay? You should be able to do that. You guys ready? All right, so step 1 says we need to sketch the angle and find theta prime. So we're going to start with, it's negative 240 degrees. So I'm going to start in standard position, and I start rotating clockwise because it's negative. So that's negative 90, negative 180, and it's not going to go all the way to 270, okay? So there's negative 240 degrees. But my reference angle is from the terminal side to the x-axis. So what is theta prime here? How far away is that terminal side to the x-axis? 60 degrees. Because when we passed 180, we needed to go to 240. That's 60 more degrees. Now, reference angles are always positive, okay, because it's a distance. How far away from the x-axis am I? All right, so step 1, you sketch the angle and find the reference angle. Step 2, you're going to take the given trig function, which is tangent, and I'm going to find the tangent 60. So we're going to look at our 30-60 right triangle. And I go to 60 degrees, and if I want tangent, it's TOA. That's opposite over adjacent, so it's radical 3. Then, step 3, I actually want to find the tangent of negative 240 degrees. In order to do that, all I do is all students take calculus. The terminal side of the angle is in the second quadrant. Sine is positive there, but tangent's negative. So my answer is negative radical 3. So what I can do when I go through this is, what we did in the previous section is we were doing all the trig functions of pi over 3, pi over 4, pi over 6. we can now move it anywhere around the unit circle and find the trig values, okay? So let's try the next one. 17 pi over 6. Yikes. Okay, we don't want to convert that to a degree as 17 pi over 6. Let's try to think in radians. Well, the first thing I notice is if I had 2 pi, 2 pi is 12 pi over 6, right? Okay, 2 pi is 12 pi over 6. So 17 pi over 6 is more than one time around, isn't it? And so now you can see the connection to my coterminal angles. 17 pi over 6 is actually 2 pi plus 5 pi over 6. Do you see that? Because 2 pi is 12 pi over 6. So this is one time around plus 5 pi over 6. So I really need to just sketch 5 pi over 6. Well, 5 pi over 6, do you remember the technique I showed you yesterday? You can cover up the 5. Pi over 6 is 30. 5 times 30 is 150. So when I go to graph this, 150, that's in the second quadrant. So if I'm at 150, what's theta prime? 30 degrees. So now this is cosecant. So I'm going to do the cosecant of the reference angle. So I'm going to look at the cosecant of 30 degrees. So I come over here to my marker board where I have my 30-60 right triangle. Cosecant is the reciprocal of what trig function? Sine, of sine. So sine is SOHCAHTOA would be 1 over 2. So cosecant is 2 over 1, or just 2. Now, you go back to the original problem, and cosecant 17 pi over 6, I have to do all students take calculus. In the second quadrant, sine is positive, so its reciprocal is positive. So that's just 2. Okay, this is a lengthy process, but this is how you do it. So now let's do sine negative 225 degrees. Alright, so I'm going to start here, standard position, I start rotating. Negative 90, negative 180, negative 225. My reference angle is how far am I from the terminal side of the angle to the x-axis. So how far away is that? 45, right? 180 to 225 is 45 degrees. So now we're going to do the sine of 45 degrees. So I go to my 45, 45 right triangle. Sine is opposite over hypotenuse, so it's 1 over radical 2, which is radical 2 over 2. And then I'm ready to answer the actual problem and find the sine of negative 225. The last thing you do is use all students take calculus to figure out is your answer positive or negative. All students take calculus, sine is positive, so it's radical 2 over 2. But I want you to notice that I'm writing out sine negative 225 degrees. That's what I was actually trying to find. Okay? Alright, let's do the next one. Cotangent 5 pi over 3. Okay, it's in radians. So I'm going to cover up the 5, and I know pi over 3 is 60. Then what's 5 times 60? 300 degrees. So let's draw 300 degrees. Now this one's positive, so I'm going to come around this way. And here's the reference angle from the terminal side of the angle to the x-axis. So what is theta prime? 60 degrees. Now I'm going to do cotangent of the reference angle, because I know how to do that. I'm going to go to my 30-60 right triangle, and I'm going from 60 degrees. Well, cotangent's the reciprocal of tangent. So tangent is opposite over adjacent. So cotangent would be adjacent over opposite. So it's 1 over radical 3 or radical 3 over 3. And then the last thing you do is rewrite the original problem. Cotangent 5 pi over 3. All students take calculus. Now remember, the C only stands for cosine. We only talk sine, cosine, tangent. So is cotangent positive or negative? Negative. Good job. Okay, are you getting the hang of it? A little bit? Alright, let's do this example and then we'll do practice problems. Alright, I found this really cool picture. I did an in-service Tuesday, teacher professional development on the Promethean board, so I learned how to put fun pictures in and stuff. So this is called a frog bot. A frog bot is a robot designed for exploring rough terrain on other planets. It can jump at a 45-degree angle and with an initial speed of 16 feet per second. On Earth, the horizontal distance d in feet traveled by a projectile launched at an angle theta and with an initial speed v in feet per second is given by this formula. So let's copy the formula down. D equals b squared over 32 sine 2 theta. And it says, how far can the frog bot jump on Earth? So we're looking for D. So let's plug in the stuff they gave us. The initial speed is the V value. So that's 16 squared. And I don't want you to get a calculator out because we're going to do this without a calculator. And the angle is 45 degrees. And I want to show you how well we can do this without a calculator. So watch, I'm not expecting you to know 16 times 16 or to ever actually work that out. Watch what we're going to do. 16 squared is 16 times 16. 2 times 45 is 90. Now watch what I can do. 16 goes into 32 2 times. 2 goes into 16, this other one, 8 times. Do you see how I did that without ever having to use a calculator? So I want you to know that sometimes when you're being asked to do problems, you don't have to necessarily go a difficult way of trying to figure it out. Now, sine 90 degrees. I told you to write down the two triangles in the circle. So what I want us to do is remember that on the unit circle, these four values, this is 90 degrees, right? So what is the sine of 90? 1. So the distance the frog bot can jump is 8 feet.
That's longer than I can go.
Yeah. Okay? Alright, what I want you to do is find a clean sheet of paper. And we're going to do some more of those problems. Okay, we're going to do some of these where we're going to go through the 3 steps. Alright, so we're going to learn how to do this without a calculator and without looking at the purple paper. We're not going to use the purple paper as a crutch. It says we want to evaluate cosine 4 pi over 3. So, and I'm going to try to do these all in radians so we can get the hang of the radians. Well, I need to make a sketch of 4 pi over 3. So I cover up the 4, and I have pi over 3 is 60. So that's 4 times 60. I really have an angle of 240 degrees. So Noah, what quadrant is 240 degrees located in?
The fourth.
No, because you go 90, 180.
Oh, the third.
It's in the third because this is 270, so I'm not quite to passing that one. So that's in the third quadrant. And then McKenna, what would be my reference angle on this one? How far away from the terminal side to the x-axis am I?
60 degrees.
60 degrees. So then we're going to do the cosine of 60 degrees. So I look at my 30, 60 right triangle, and so I strongly recommend on tonight's homework, and whether it's the book work or the worksheet, you write out the two triangles in the circle, and you're constantly looking at them, okay? So cosine of 60, Andrew, what is the cosine of 60?
That would be radical 3 over 2.
No?
That's all.
Henry, what's cosine 60?
Yeah. 'cause
1
it's
over 2 is
adjacent.
the adjacent,
I
yeah.
get it.
So it's 1 over 2. And then I want to do the original problem. And you do all students take calculus. I'm in the third quadrant, so cosine is negative there, okay? All right, let's do sine 11 pi over 6. All right, the first thing we need to do is we need to figure out what is 11 pi over 6. So Elena, if I have pi over 6 and that's 30 degrees, what's 11 times 30?
33. Wait, no, 330.
330. All right, then Hannah, what quadrant am I in if I graph that?
You will be in the third.
Nope.
The third.
See, there's 180, here's 270. I'm in the fourth. I'm in the fourth quadrant, okay? All right, then Megan, what would be the reference angle? How far away from the x-axis am I?
30 degrees.
30 degrees. Okay, now I'm going to want to do the sine of 30 degrees. So Carmel, what is the sine of 30?
It would be 1 over radical 3, which would be radical.
No. Sine 30, SOHCAHTOA. Opposite over hypotenuse. 1 over 2, okay? Now I'm going to do my original problem, sine 11 pi over 6. All students take calculus. It's a negative. Okay, what if I ask you for tangent 7 pi over 4? All right, well, pi over 4 is how many degrees? 45. I do not want to take 7 times 45, okay? What I need you to remember, though, is you remember when we did the unit circle and I said to you, hey, there's a pattern with the 45 degrees when you're doing radians? Do you remember this? That it went pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So when I'm graphing this, I'm actually in the fourth quadrant, and it's the halfway mark. So theta prime is 45 degrees. So I'm going to do the tangent 45 degrees. So you guys want to remember this. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Those are the halfway marks in each quadrant. So look at my 45, 45 right triangle, and what's the tangent 45? 1. And then if I want the tangent 7 pi over 4, I do all students take calculus. Is it positive or negative? Beautiful. It's -1.